So we're now going to start covering a case study that's relevant for the next programming assignment having to do with regular expressions. And we're going to talk about this case study, which is case study ex45, that searches for the words and phrases in the works of William Shakespeare. There's some utility classes that we're using in conjunction with Java streams. We have this thing called BardDataFactory, which is going to be creating input from the works of Shakespeare, and something we call RegexUtils, which is used to make some regular expressions. Some of this stuff is relevant for the next programming assignment that you guys have as well. So what this program does is it shows how you can use regular expressions in conjunction with Java sequential streams to search the complete works of William Shakespeare for certain words and phrases. So for example, if you have some phrases we're going to be looking for the word Lord, and Lord followed by true or false somewhere in the expression, in the sentence. And so if you take a look here, we can see the number of words that match in the works of Shakespeare. There are 13 works that match this phrase out of a total of 37 works, and it displays it like this. So we'll talk about that in more detail in a second. The project is organized into several files and packages. It's not a Spring project, it's just a good old Java project, but it shows off some cool stuff, and you can get it in the ex45 folder in my Java 8 directory in the live lessons GitHub repository. So we have a main test driver program. That's the one that kind of does all the coordinating and looking for words and phrases in the works of Shakespeare. And there's a couple of utility classes that we use in order to be able to create the input and be able to search for the regular expressions, create the regular expressions we're going to be used to search for. And then we have the complete works of Shakespeare here as well, which you're welcome to play around with. You can get it from the web. So let's first start by talking about the BardDataFactory. So if you recall, the Bard is the nickname that they gave to William Shakespeare, the Bard of Avon. And this is a class that's going to use Java streams to read the contents of a text file containing the works of Shakespeare, and then return this as a list of strings. And each string will have a work of Shakespeare in it. So you can see here that this is a so-called utility class. A utility class in Java has only static methods. It's defined as final, so it can't be subclassed. It has no non-static state, and it has a private constructor. That means it's just used as essentially a namespace for methods. Java doesn't have standalone functions the way that C and C++ do. So if you want the same type of effect, you have to use a utility class. There's a file that is going to be associated with a field in the ex45 driver class, and that's where we're going to get the work of Shakespeare to read from. And there's a getInput method here defined on BardDataFactory that's used to open that file. And what happens here is each work is separated by the @ sign, which otherwise does not appear in Shakespeare. And you're going to see here that this is going to be having each of the texts for the works of Shakespeare separated by an @ sign. And we'll see how we use that in just a second in a cool way. So here's the getInput method. As you can see here, this comes from this file. And what it's going to do is it's going to take the string containing the file name and the split string, which is this @ character, as you can see here with the @ string. And then what it's going to do is it's going to open up the file that contains the work of Shakespeare. It's going to read all the contents of the file into memory in a single string. So we're going to have one string that has all the works of Shakespeare, which is like 5 megabytes or so. And then we're going to use regular expression features to take the splitter string, compile that into a so-called pattern, and then we're going to split the bytes, which is the works of Shakespeare, up by the @ sign. So we're going to end up with a stream of strings. Each one corresponds to where we split it based on the @ sign. The @ sign is lost. We don't deal with the @ sign. It's just used for splitting. And then we filter out anything that might be empty. There's really nothing empty, but if there were, we would be filtered out, so there's no empty strings. And then we return the whole thing as a list of strings. So we get back a list of strings from our getInputFactory method. Let's talk a little bit about the methods in the regular expression utility class. So the regular expression utility class provides helper methods for handling Java regular expressions. You can get that over here in this file in the utils folder in this project. And we'll take a look at each of the methods that are interesting. This is one that you'll also get a chance to use for the assignment. So make regex converts a list of strings containing queries into a single regular expression. And what it's going to do is the return string will match any string that contains any of the queries as whole words, regardless of the case, whether it be capitalized or lowercase. And you'll see here how we are going to use the Java Stream API for doing these transformations. So here's an example. We're going to have a list, cat, dog, mouse, and socks. And then we're going to call make regex on that list. And it's going to give us back a string. And this is what the string is going to look like. And believe it or not, what this regular expression says is do comparisons in a way that ignores case. So be case insensitive. That's what the question mark lowercase I means. And then it says match anything, whether lower or uppercase, that has anything followed by cat or dog or mouse or socks, followed by anything. And so that's what the regular expression matching is going to do. So it's going to create that string. And then we're going to use that string to do the actual matches. And we're also going to use another method, which is going to return the first line of a given input string, which is the title of the work of Shakespeare. And this also uses pattern matching and Java regular expressions along with the Stream API. So in this case, we're going to have this method called getFirstLine. We give it a work of Shakespeare, and it gives us back just the first line. There's also some stuff that's not too dissimilar to that you do in your programming assignment. So this is also relevant there as well. Okay, so now we're going to go ahead and take a look at those parts of this particular program. So here we are in the ex45 project. This is the complete works of Shakespeare. I won't read it to you. It'd take a long time. But basically, these are the works of Shakespeare that are separated by the comma separators, or the at sign separators. So you can see here is the at sign, and that separates all the works of Shakespeare. Let's go take a look at the two utility classes. First, here's BardDataFactory. And you can see that this is indeed something that I should say public final, because it's a utility class, so it should be marked as final. It has a private constructor, and it only has static methods. In this case, it has a single static method. And the static method does what I showed you before, where you give it a file name and a splitter, and it creates you a list of strings, which in this case, of course, will contain the works of Shakespeare. Let's go take a look at the RegexUtils. That's a bit more interesting. This is also a utility class, so you can see it's public final, private constructor, and it's got two methods in here, which are very interesting. This is the first one we're going to look at. This is called make regex. You can see it takes a list of strings, which are the queries, and it's going to convert that list of strings into a single string, which is this regular expression, which is going to be case insensitive. And as we talked about before, it'll be anything followed by either first query, second query, third query, and so on, each of which are elements in that list of string queries that are passed as parameters. How does it do this? Well, the first thing it does is it uses the stream method to convert this list of strings into a stream of strings. And then it goes ahead and it uses the map intermediate operation to quote each of the strings. And it uses the pattern quote method. And what that does is that will encode any funky characters so that they will not be treated as regular expressions, but instead be treated as literals. So that'll encode things properly there. And then we do total magic with Java collect. This is super cool. So we use collect, so we now have a stream of quoted strings. And we'll go ahead and use the joining collector. So what this is going to do is it's going to put a vertical bar between each of the elements in the string. And then we're going to add this as the prefix, this being this funky thing down here. So this is the prefix that's added before everything we're about to collect. And this is the suffix that's added after everything we collect. So you can see here's the prefix up there. Actually, it goes to here. There's the prefix. And then here's the suffix. And then all the stuff that goes there is going to be properly connected together using the joining collector. So it separates everything with the vertical bar. So super cool little helper class. I had fun last semester when I taught this using ChatGPT. I started out with code that did this in a more hard-coded manner. And I worked with ChatGPT, and we came up with this very cool solution, which ironically enough, I didn't even realize there was a version of this that would work like this, where you could add the suffixes and prefixes and so on. So that was pretty neat when I got that working with the joining collector. So that's basically what the RegexUtils does. And those two things are very useful, and you'll end up using something similar to that in your assignment 1C. Here, by the way, is the first line, get first line method. This is pretty cool, too. You take a big string as an input, which is a complete work of Shakespeare, and we're going to go ahead and compile it. So this is a regular expression that only matches the first line of multi-line input. So it'll just match the very first line. Believe it or not, that's what that is. And then we compile that. We associate that compiled regular expression with the input string, and then we go ahead and check to see if we can find something that matches, which will be the first word, the first line. And so we'll find that thing, and then we'll transform that into a stream of one string, and then we return that one string. There's all kinds of ways to do this. This is the way that I came up with working with ChatGPT. I thought it was kind of cool. Another thing that's worth noting here, because regular expressions are a bit mystical, once again, ChatGPT helps you substantially, because you can ask it, how do I generate a regular expression that will match only the first line of multi-line input in a string, or something like that? And it'll come back and tell you, oh, here's the strange Java incantation in order to make that work. So great tool for working with rather obscure programming language features, where you don't have to learn all the obscurity, you just have to learn how to express it in natural language, and then work with ChatGPT to make sure that you get the output that makes sense. So once again, augmented intelligence, not artificial intelligence. So those are a couple of fun regular expression features, and we'll then use them in the next part of the lesson when we talk about the actual driver program here.